to show you how to create a LoRaWAN node, this time using the SAMD microcontroller boards. You cannot find a solution on the web which create a LoRaWAN node using this type of boards, and using the LMIC library specifically, because the LMIC library is has been written or created based on the ATmega and AVR boards. So let's start. First you need to wire the components together. So you need the pin map of the Arduino Nano IoT. For example, in this scenario that you can see the pins, we are using very easily the 3.3 volt ground, pin 2, 3, 4, and the SPI pins, the 11 and the 12, and in total I will show you also in a Word file to simplify to understand which pins are connecting to which part between the components. Also in the other side we have the Lora Bee pins out, as you can see. Unfortunately there are other pins out, maybe they may cause you mistake. Please be sure that the pin out that you found is exactly working, because some of these Lora Bee pins out I found are related to the other previous versions and not working. So this is the best pins out that I found, and it works correctly with my scenario. The pins that we use is MCCI DO0, DO1, DO2, NSS, SCK, and here 3.3 volt, MISO, and yes, the ground. Okay, so for the first step, I want to explain also this that as the LMIC library which exists on the web, and you can see it is the most famous library for creating the LoRaWAN node and working with the LoRaWAN server. And unfortunately all the scenarios existed on the web are based on the ATmega microcontrollers like Arduino Uno, Mini, Nano, BLE, or other boards, because in the Nano IoT 33 we have ARM microcontroller which is based on SAMD 21, and the pin maps is a little bit different. For example, if we don't have the reset pin here, while in other scenario you should put it and set it. And okay, the pin maps are like this, but first we have to download the correct MCCI LMIC library, and the most recent, for example, you can see in 10 months ago the folders has been changed. So the Katana is the most correct and useful LMIC library for me. It works correctly, and so you need to download the code like this, download zip, and the Arduino LMIC master, the name, and you have to go to file, include library, add zip library, and from the download folder give the right name. For me is Arduino LMIC master 1 zip file. Press OK and close your Arduino IDE and then reopen it and go to file example, and you can see the LMIC LORAWAN MCCI library with these examples. Then you need to open the TTN OTAA, because here we are using this. Maybe you are also able to use the TTN ABP over the activation by personalization, but here because of the simplicity and also it's more common to use the over-there activation scenario. Previously I have opened it, and so just I explain which parts you need to replace. Previously I have set the app UI and the VUI and the app key from the TTN application previously, which if you need, it is not very difficult. I think everyone knows, and this everyone know. And then just the important part is the LMIC pin map. As you can see, and the NSS set to 6, RST should be on set, and the DO 0, DO1 and the DO2 like 2, 3 and 4, as you can see in this way. Then I connect my board to the PC, and then you should choose the Nano IoT 33 IoT board, which is located in the Arduino SAMD. Previously you have to install this Arduino SAMD by going to the board manager and search SAMD, and as you can see the Arduino SAMD boards has been previously for me installed. It includes all these boards inside. Also you can use this scenario for all of these boards that you can see, all of these MKR boards, Arduino Tian M0 and all of these boards. Okay, when I choose the correct board and the correct port, then you don't need to change anything, just you have to upload the code, and by watching the terminal you can monitor the result. Okay, now you can see after a short time the keys has been shown and in TTN. Then we can check if the correct payload is coming. Here I have defined a decoder, so the payloads are like this. Now I can easily remove the payload, format the decoder and you can see the known. I changed the time interval to okay, this is the hello world. If you decode it, you can easily as you can see in this online decoder, you can see the hello world correctly here. Okay, that's it. Thank you very much for your time, and as always, see you very soon, and good luck and have a nice day. Thank you. Moreover, if you could successfully build a LoRaWAN node using this solution, please note your board type and the scenario you used, and always I'm available for any question in the comment. I will be happy to respond for any question. Thank you.
Maybach.